Hello, ladies and gentlemen, and I'd like to talk to you about a few ideas from grade 9, and then we're going to expand those ideas and see how we can use them with some different notation and apply them to our calculus methods. So the first thing that we should do is we should start discussing a Cartesian plane. So this would be our x-axis and our y-axis. And let's put on just a general nondescript function. So here's a function, f of x. Now for this function f of x, let's choose a particular x value, and we're going to call that x sub 1. I'm going to zoom in here a little bit. Make this a little bit bigger for you, maybe focus it a little bit, see if that's any nicer. And for that particular x sub 1, for that x value, on this function there is an associated y value that we shall call y sub 1. So we got x sub 1 and y sub 1, that makes a little bit of sense, and that's going to be a new point, x sub 1, y 1. And that's going to be the point A, and it has a place on that curve. Now if I come down the x-axis a little bit more, I'm going to choose another value of x. Now if I'm choosing another value of x, I can't call it x sub 1. So the next logical choice is to call it x sub 2. And that's going to have a corresponding y value to it of y sub 2. And that would indicate a point, therefore. And we can't call it A, so we'll call it B, and it will be x2, y2. And there you go. Terribly exciting stuff, I have to agree. Now, if I was to join those 2 points with a straight line, then I'd be creating something new. I'd be creating a new geometric. Ooh, green doesn't show up so well. Let's try going over it with black and see if it looks any better on the screen. There you go. And that new geometric object is called a secant. And a secant, by definition, is a line that goes through 2 points on a curve. And you need to know that, okay? So a secant is a line that will go through 2 points on a curve. And this particular secant, we can call it secant AB, because it's going through my 2 points of A and B. Now, let's talk about a property of this secant. So back in grade 9, we talked an awful lot about something called slope. And slope, we discussed, was rise over run. And we talked an awful lot about that in grade 9. If I make this a little bit smaller, I'll be able to see a little bit more of what I'm doing. Okay, maybe I need to check the focus again. Now, rise is going to be this distance over here. Now unfortunately I got to go right through this for my run, and I'm going to go up through here for my rise. So here's my rise and here's my run, and you'll notice that my rise is the vertical change that happens between the point A and point B, and my run is the horizontal change as I go from point A to point B. Now this vertical change is going to be the difference between this y value and this y value. So it's actually going to be y2 minus y1. That'll be the numerical change between those 2 values. And this run value is going to be the numerical change of the larger x value subtract the smaller x value. And so that's going to be x2 minus x1. And so that means that my rise over run could be written as y2 minus y1 over x2 minus x1. Now, sometime in grade 11, I think chemistry started using delta. Now that's not a triangle, that is the Greek letter delta, and they would have said delta y over delta x. And the use of this delta means change. So we're talking about the change in y and the change in x. And so when I talk about the slope of the secant here, slope of the secant AB is going to be equal to y2 minus y1 over x2 minus x1. And there you go. Nothing very exciting about that. If we wanted to talk about the equation of that secant, so I'm going to come out a little bit more. And let's say we wanted to start talking about the equation of the secant. Now that's my short form for equation, an EQ with apostrophe N and a line over. So the equation of a line. Now that's important. The secant is a line. It's just a line. It's just a particular line that cuts through a particular curve, f of x, at 2 points. So the equation of a line is given by, now in grade 9 you spent a lot of time with this, y equals mx plus b. This is the slope y-intercept equation of a line. And what that means is that we would have to know the slope and you would have to know the y-intercept. And the y-intercept is the point where x equals 0. And if we knew those two things, then we could put them in for m and b, and we would have the equation of a line. Now, we also are going to create a new formula for the equation of a line, and I'm going to derive that for you. Now, it's going to be made from, starting with slope, is y2 minus y1 over x2 minus x1. And what we're going to do is we're going to cross multiply. So that's m over 1. Cross multiplying gives us m x2 minus x1 equals y2 minus y1. Rearranging is going to give us y2 minus y1 equals m x2 minus x1. And what happens here is this is going to be called the point slope equation of a line. Now, it really should be called any point slope equation of a line, because instead of insisting on us knowing the b-intercept, any point at all is going to be given. So we're going to know the values of x1 and y1. So we're going to be given x1 and y1. We're going to figure that out. We're going to know the slope. And we're going to allow y2 and x2 to be the variables in the actual line equation. So this is actually going to be written as y minus y1 equals m x minus x1. And that is the formula that you're going to need to memorize or derive for calculus, and we're going to use it an awful lot. All of our answers we're going to put in standard form, which is ax. So standard form is going to be ax plus by plus c equals 0. And we're going to want a to be greater than or equal to 0. And this is going to be standard form. So our final answers will be in this form. But this is the formula we're going to be using when we know a particular point on the line and its slope. And I'll do a quick example of that with you right now. So why don't I take, again, a Cartesian plane. We'll draw some undescript function. Why don't we say that this point is given by, and I'm making this up, why don't we say this is 2, and we'll make this 3. So a is 2 comma 3. And why don't we move up to a new point b? And again, I'm making this up. I'm saying that this will be 5 and this will be 7. So that comes down. So the new x value is 5 and our new y value is 7. And the secant between a and b is going to be that line right there. So if I want to come up with the slope of AB, it's going to be delta y over delta x. So it's going to be y2 minus y1 over x2 minus x1. And in this case, I'm going to make this my second point. So this will be x1, y1. And I'm going to make this my first point, in which case I'm going to have 7 minus 3 over top of 5 minus 2. Work that out. We're going to get 4 over 3. And that's our slope. Now let's say we wanted the equation of AB? Well, if I want the equation of AB, I'm going to make use of my new equation. The point that I'm going to use could be either one of these points, because it can be any point on the line. So let's use 2 and 3 because it's convenient. My slope has been calculated to be 4 over 3. So there's going to be y minus 3 equals 4 over 3x minus 2. We're not going to leave it like this. Remember, our final answer, we want it to be in standard form. So I'm going to do something here. I'm going to do something that's called clearing the fractions. You should have learned this in previous grades, but if not, it's a cute little way of getting rid of this denominator of 3. To get rid of that 3, I'm going to multiply this side by 3. What's going to happen is they're going to reduce out. So I multiplied that side by 3. If I'm going to do that, I also have to multiply that side by 3. So I'm going to get 3y minus 9 equals 4x minus 2. That's called clearing the fractions because I no longer have a denominator, which means I no longer have a fraction. You're going to do that several times in this course, and we'll see it as it pops up and we'll discuss it. Now I need to move this around, so I'm going to get 4x, take the 3y over the other side, take the 9 over the other side, and that's going to be negative 8. The whole thing's going to be equal to 0. So the equation of my line is 4x minus 3y plus 1 equals 0. That is the equation of that secant line, given that these points lie on that function. And that's how we're going to work these things out. A couple of things to keep in mind here. It wouldn't have mattered if I decided to make this my point 1 and this my point 2. Let's see how that would have worked. If I made this point 1 and this point 2 in this case, then y2 minus y1 over x2 minus x1 would simply have been 3 minus 7 over top of 2 minus 5, negative 4 over negative 3. You notice that negatives will cancel each other out, and we end up with the same slope. And that's because the slope is going to be rise over run. So if I take my run this way to be positive, then my rise is positive. If I take my run to be negative, then my rise is negative, and everything works out just lovely. Also, it wouldn't have mattered if I used the other point on the line, and everything here would have worked out just the same. Maybe I'll do that just to prove it to you. So instead, let's use the point 5, 7. So that means that it would be, I'll use the red, so it'll be y minus 7 equals 4 over 3, x minus 5. Multiply both sides by 3. 3y minus 21 equals 4x minus 20. So it's going to be 4x minus 3y. The negative 21 becomes positive 21. Take away 20 is 1 equals 0. And lo and behold, we are good. All right, a little bit of review of grade 9, a little bit of review of secants, a little bit of review of algebra. That's good for our first video.